Alright, let's talk about curves of best fit now. So a curve is a parabola. You would remember this probably from our quadratic unit where we factored and solved things. And we have two types of curves. We have positive curves, which make a U. And we've got negative curves that kind of make an upside down U or an N. So we've got our positive curves, which are ax squared plus bx plus c. And we've got our negative ones, which are negative ax squared plus bx plus c. So two types of curves of best fit. So some keywords here. You can say curve of best fit. You can say quadratic curve of best fit. You could say which quadratic model. Anything that says quadratic or curve is going to be one of these. So let's go see a problem real quick. So next slide, it says we are launching a rocket. They're tracking the path of this rocket through the air and recording exactly how high it is in the air at specific times. So the table shows their collected data. And the first thing it says is it a linear, which means a line, or is it quadratic? And you got to think about what they're doing. They're shooting a rocket up into the air and then seeing what height they're at. So that is a negative curve right there. So that is a quadratic. So now we need to find the equation of best fit, or the curve of best fit. So we are going to get into our calculator. We're going to hit our stat key. We're going to go, so again, right here, stat key. We're going to go in and we're going to hit that first one. We're going to edit our list, so let's enter it. Make sure you're in L1 and L2. So I'm going to go ahead and enter 1, hit enter. Then I'm going to go to my next one, which is right here, 3, hit enter. Then I have 5, and then 7, and then 9, and then 11, and then I've got 13, 15, and 17. Alright, so we got a lot of data right there. Then we're going to arrow over, go to L2. So L1 is our X values, L2 is going to be our Y values. So we're going to go and put in the bottom side of my data. Now the important thing here is that anything on the top lines up with anything on the bottom. So that 1 right here needs to line up with the 5 below it. So over here I'm going to put the 5. If you go in order, no problem. Sometimes you forget something though, and that can throw you off. So entering all those data values, be careful not to miss anything, miss any numbers, or mistype anything, or you'll get the wrong answer. And one more. Okay. So this rocket's going up in the air and then falling back to the earth. So let's go ahead and find our curve of best fit. So now that you got your data entered, hit the stat button again. So right here, go over this time to calc. So right here is where we're heading. So you get there with the this arrow. Now you've got a bunch of options. We would have done 4 if it was a line of best fit. So instead we're going to go to 5, quadratic. So I'm going to hit the number 5. It'll take me there directly. Now your newer calculators have a few more options through here. Don't worry about that. When you hit it, just go down to calculator at the bottom there. And there we go. We've got all the information we need. So we need to say that this is y equals ax squared plus bx plus c. And we're going to write our a value in here, our b value, and our c value. I don't think it's said to round anywhere, so I'm going to round to the 10th spot each time, so 1 decimal place. So my a is going to be negative 1.2. My 6 is going to throw that 1 up, so that's negative 1.2 x squared plus, we're going to say 20.8 because that 8 is going to round the 7 up, so 20.8x. And then saying, instead of saying plus c, because it's a negative c, I'm going to say minus c, and it's 15.3. And there you go. You've got your equation of best fit. Alright, based on your equation, would the rocket be higher in the air at 6 seconds or 12 seconds? So we're going to try two things out. So this is really 2 values to plug in. They're also in time, so we know it's in our x value, so we know we're going to plug it in for the x. So I'm just going to go to my calculator real quick, and I'm going to plug this in with 6 in it, and then I'm going to plug this in with 12 in it, and see which one of those is higher in the air. So we've got our negative 1.2 1.2, whoops, 1.2 times our x squared, and again we said the x is going to be 6 seconds for the first one, so 6 squared plus 20.8 times an x again, so we're going to put in 6 again, right there, and then minus 15.3. Hit enter. For 6 seconds, it's going to be 66.3 feet in the air. Let's see if 12 seconds can beat that. Maybe it's higher or maybe it's falling back to Earth at that time. So we're going to take what we had before and we're instead going to plug in the 12 seconds instead of the 6. So the negative 1.2 times 12 squared plus 20.8 times 12 minus 15.3. So almost identical statements, just the first one we hit 6 plugged in, now we have 12 plugged in. And it is falling back to the ground. We see it 61.5 feet. So it would be higher in the air at 6 seconds. All right, let's try another one. So we're back in our calculator. We have a new list. This time we're talking about marathon runners. And this makes sense because if you're younger, you're probably running faster up to a certain point, and then once you get older, you probably start slowing down again. So we're going to go ahead and hit our stat. We're going to hit edit again. So enter right in there. We need to clear out this data. So up, hit clear, hit down, clears out the whole list. Hit clear, hit down, clears out the whole list. So we want the quadratic curve of best fit. So here we go. We got 19, we got 34, we got 41, 46, 50, and 55. Over to list 2, which is our y values, our bottom. So 182, 151, 170, 168, 172, and 177. Alright, got all that information in. So I'm back to the stat key right here. Over to calculate again. So over right here. And then we're going to go down to number 5. So I'm going to hit my 5 button right here. So my quadratic regression, that's what the reg stands for, gives us our value. So I am going to write this down. Let me make this a little smaller here so I can see the calculator at the same time. So we've got y equals, our a is going to be 0.06. We're going to take that one all the way to the 10th value just because we don't have a really a 10th value there. Sorry, we're going to take to the 100th because we don't really have a 10th value there. Make it more accurate. Plus our bx, which is not going to be a plus, it's going to be subtract because we've got a negative value right there. So 4.4x, and then plus the c right there, 242, and we're going to leave it there because it's just going to round to 0.0. It's a 4 right there. All right, back to full screen. So we've got our equation ready to go. There it is, check yours. And the next thing we want to do is, using this model, what would be the time for the fastest 29-year-old? So we're looking at time for a 29-year-old, which is going to be our x value again. So x is going to be 29. So we're going to take that and we're going to plug it in here. We're going to take that and we're going to plug it in there. So to our calculator, we've got 0.06 times 29 squared minus 4.4 times 29, and then plus 242. So this will tell us about how fast a 29-year-old is. And he's going to finish this race in about 164 minutes. It says to the nearest 100, so let's keep going a little bit there. 0.86. All right. So there you go.